All right, so we're looking at 9.1 today, solving equations. An equation is a statement that two algebraic expressions are equal. So an example of that, simple example of that is x plus 5 equal to 7. Your solution is going to be a value or values, depending on the type of equations that you have, but value that will make an equation true. So in this case, the solution for x or for this equation would be 2. So this 2, if you ever want to check it, let me go back here. Okay, there we go. If you ever want to check, you can always take that 2 and plug it back into the equation. And if it creates that true statement, then you know it's a solution. So 2 plus 5 is equal to 7. So that's how you know it is the solution for that equation. And whenever you're trying to solve an equation, you should be asking you're asking the question, when is this statement true, or when is this equation true? So in this case, we would be saying when is x plus 5 equal to 7? And the answer is when x is equal to 2. So you always want to know, when is your equation true? And that's what you're trying to find the answer to. When is that equation true? All right. Or as always, if I scroll it too fast, let me know. So we will be solving by what are called opposite operations, talking about operations that undo what the other one does. Addition and subtraction are opposite operations. Multiplication and division are opposite operations. So your goal is to get x by itself. All right. Goal is to get x by itself. You want to have x equal to. So you need to undo what's being done to x. So we have x plus 5 equal to 7. Going back to that original equation that I presented to you. So if I want to solve or undo that addition of 5, I need to subtract. Let me go purple. 5. Also, when we look at our equation, is split up into the right side and left side of your equal sign. Whatever you do to the left side, you have to do to the right in order to keep your equivalency. So if I subtract 5 from the left side, I need to subtract 5 from the right side as well. Once again, in order to keep that equivalency. And then what happens is that, let's go blue. 5s will cancel on the left, leaving me with just x. And then 7 minus 5 on the right is 2. And that is my solution. And that is the foundation of solving equations. You're doing opposite operations to undo what's being done to your variable. All right. So looking at a few more one-step equations in order to be able to solve. We have y minus 10 equal to 20. If I'm trying to solve for y, I need to add 10 to both sides of my equation. Tens cancel, and y is equal to 30. For 5a equal to 13, somebody said something. As far as your email, I need to check. I'll check it out before the day is out and respond. So we have 5a equal to 13. So that's 5 times a. So to undo the multiplication of 5, you would divide both sides by 5. 5 over 5 cancel, leaves you with 13 over 5. Now, you don't have to do anything else with that. You are expected to simplify fractions, but you don't have to convert them to decimals or mixed numbers unless they specifically ask. And majority of the time, they don't. So they are expecting you to reduce like that. So if you have a fraction like 4 over 6, you are expected to cancel out the 2's and be left with 2 over 3. But if it's 13 over 5, there's nothing that can simplify into that. And so leaving it as 13 over 5 is fine. Then the last one, x over 9. That's x divided by 9. So I'm going to multiply both sides by that 9. 9's cancel on the left to leave me with x. And I have a solution of 99. So questions, any questions on those one-step equations?
Okay, I was just, Mr. Vincent, Mr. Tucker.
Mm-hmm.
I was just thinking about the last one you did. Could you do another one?
When you say the last one, what you mean? You talking about this one right here?
The third problem. Yes, sir.
All right. So are you talking about just from the idea? Because you know I have more problems to do. Uh, is there something in particular you want to see in this scenario that caused you issue? Just want to make
I think I
sure.
just got lost. I was still writing the other one. I don't think I heard it. But okay, if you're gonna do another one, I'll just wait.
Oh yeah, I got plenty more now. You know, I got math for days if you want. No, I just mess with you. But just to
Okay.
make sure we're clear on this one, if you say this third one right here, we were dividing. It was x divided by 9 equal to 11. So remember, we're talking about doing the opposite operation in order to solve. So if I'm dividing by 9, then that means I need to multiply both sides by 9 in order to get this 9 off of x. And
Okay,
so that,
thank you.
yeah, not a problem. And so that'll just be x on the left and then 11 times 9 on the right, which will give us 99. All right. Anybody else before we put some more to it? Good. All right, let me erase some of this stuff so we can walk through it. All right. So here we have 2x plus 9, plus 1, excuse me, equal to 7. Now we have what's being done to our x. We have the multiplication of 2 and the addition of 1. Now we could divide by 2 first, but that would create fractions for us unnecessarily. So that wouldn't be the most efficient way to take care of this problem. It's always best to go ahead and move, you know, whatever separate term there is. So in other words, 1 in this case, subtract 1 from both sides. 1's cancel on the left, leaving you with 2x. 7 minus 1 is 6. And then we have 2x equal to 6. So divide by 2, and that'll be x equal to 3. All right, make sure we're okay with that. So we subtracted 1 from both sides first to cancel out the plus 1 on the left. Then we divide it by 2 so that we can have x equal to 3. All right. All right, next one. 5x plus 9 equal to 23 minus 2x. So notice the difference in this one is that we have x term in two different places. They're on different sides of our equation. So whenever you have this type of scenario, your goal should be to get all of your terms with x on one side, all of your terms without x to the other side. All right. See, somebody said something. Oh, it's all good. You're all right. So now it doesn't matter which term you decide to move. We have 4 different terms here. Doesn't matter which one you decide to move first. As long as you do it correctly mathematically, you'll still get the same result. I'm going to add 2x to both sides. So 2x cancels on the right. On the left, 5x plus 2x is 7x plus 9 equal to 23. Now I need to take the 9 over by subtracting 9 from both sides. 9's cancel on the left. And 23 minus 9 is 14. Divide both sides by 7. And our solution is x equal to 2. All right, questions? All right, scrolling up. All right, next one. 8x minus 3 times 4x minus 5 equal to negative 2x plus 6. First thing we want to do is get access to this x right here that's inside of the parentheses. Can't do that until we get rid of the parentheses, so we need to distribute negative 3 to each term that's in the parentheses. So then that'll give me 8x minus 12x plus 15 equal to negative 2x plus 6. All right, now both of our x terms are on the same side of the equation, so I can go ahead and add those together. So remember, before we go back to this last problem, I had x on different sides of the equal sign. So that's why we had to do opposite signs. But since they're on the same side, I can add both of these together and get this 4x right here. So 8x minus 12x gives me this 4x, negative 4x. All right. Once again, we have x terms on different sides of the equation. Get all of your terms with x on one side, all of your terms without x to the other. I'm going to add 4x. So the 4x cancels on the left. And that leaves me with 15. And then on the right, negative 2x plus 4x is 2x. And that's plus 6. Now I take the 6 over by subtraction. And that's 9 equal to 2x. And we'll finish it off by dividing by 2. X is equal to 9 over 2. All right, questions? Any questions? All right, thank you, thank you. All right, so the next one. This time we have fractions involved. Now, if you want to keep the fractions and solve with the fractions, that's up to you. But we could do what we call clearing out your fractions, in which we can get rid of the fractions altogether. So we want to find the LCD if you want to clear out your fractions. And talking about the least common denominator of 4 and 3. So that's the smallest number that each denominator can divide into evenly. So when you're talking about your LCD, that's going to be the smallest number that each denominator can divide into evenly. All right. In this case, it's going to be 12. Excuse me. 4 and 3 can divide into 12 evenly. That's the smallest number they can divide into evenly. All right. Once you find the LCD, you're going to multiply each numerator by the LCD. So notice I didn't say numerator and denominator. You're going to multiply each numerator by the LCD. So we're going to take that 12 and, like I said, multiply it to each numerator, whether it has a denominator or not. Going to multiply it to each numerator. So that's why we have 12 times 3x over 4 minus 12 times 6 equal to 12 times x over 3 minus 12 times 1. All right. So then we're going to simplify. So what we mean by that is that, we multiply each numerator by 12. So those ones that had the denominators, they should be able to divide into the LCD. That 4 divides into 12 and leaves you with 3. And that 3 divides into 12 and leaves you with 4. So we have the result of this expression now. 3 times 3x minus 12 times 6 equal to 4 times x minus 12 times 1. Three times 3 is 9, 12 times 6 is 72, 4 times x is just 4x, and then 12 times 1 is 12. Make sure we're all right. All right, so once again, we have variables on both sides of our equations. So I'm going to take 4x to the other side by subtracting. That leaves me with 5x minus 72 equal to negative 12. Add 72 to both sides. So that'd be 5x equal to negative 12 plus 72, which will give you 60. Finish it all by dividing by 5. And x is equal to 12. All right, any questions?
No, that's it.
All right, thanks, sir. Appreciate that. So let's try that again. Let me erase some of this stuff. All right, so here we have 2x minus 3 over 3 plus 1 over 2 equal to 5 over 6. And our LCD, remember we were looking at 3, 2, and 6. Smallest number that 3, 2, and 6 can divide into evenly is the number 6, because 6 can divide into itself as well. So we take that LCD and multiply it to each numerator. So what's going to happen there is 3 is going to go into 6, leave you with 2. 2 will go into 6, leaves you with 3. 6 goes into 6 and leaves you with 1. And so we have that expression right there left over after your denominators cancel out. 2 times the quantity of 2x minus 3 plus 3 times 1 equal to 1 times 5. All right, so we can go ahead and go about solving. Distribute that 2 and multiply the 3 and times 1 and 1 times 5. So we have 4x minus 6 plus 3 equal to 5. So negative 6 plus 3, add those together. That'll give you negative 3. So that's 4x minus 3 equal to 5. All right, then we can add 3 to both sides. That'll be 4x equal to 8. Divide by 4, x is going to be equal to 2. All right, any questions? Any questions? Make sure we're all right. All right. Don't worry about that scribble. So now the last thing of this section is solving for a specified variable. So remember what we did last example, we're solving to get a specific number for our solution. So whenever you solve for a specified variable, you may not get an actual like solid number. You're trying to get everything that's not that variable to the other side of the equation. So here, my eraser still on. So here when we're looking to solve for L, we want to get this L by itself and push everything else to the other side of the equation. All right. So when we look at solving this, you can't forget that these numbers represent, these letters represent numbers. And so you're supposed to treat those the same way we would treat numbers. So when I look at this over here, if I have 2L, 5 equal to 2L plus 7, and I want to solve for L, the first thing I would do is move the 7. I would subtract 7 from both sides. So the same thing happens here when I'm looking at P equal to 2L plus 2W. I would subtract 2W from both sides. All right. So subtracting 2W from both sides. Let me see something. All right. So 2W cancels on the right, and that leaves me with P minus 2W. You can't combine them because you don't know what W is, you don't know what P is. So you have P minus 2W equal to L. So that's where you're at right here. Equal to 2L, excuse me. So now you want to get this 2 off of the L. So you divide both sides by the 2. 2's cancel. And this is our answer. P minus 2W over 2 equal to L. Now I'm going to talk about how you could reduce if you want it and what's the wrong way to reduce. But let's just make sure everybody's okay with getting right here. Answer is P minus 2W over 2, and that is L. All right. So now when looking at this problem, looking at this final answer, there is a way to reduce it. There's a right way and a wrong way to reduce it. And a lot of people tend to go with the wrong way because they see those 2's. And the first thing that people want to do is cancel out those 2's. That's what I'm talking about right here. Looking at down here, down bottom. They cancel out the 2's and then they'll write the answer as P minus W. Well, that is the incorrect way of doing that. So make sure you're careful with this. If you're going to reduce further up here, would be the correct way of doing it. So that 2 has to go into each term in the numerator. So you have to do P over 2 and then minus 2W over 2. Once you do that, then if you can reduce, you go ahead and do so, and those 2's can cancel. And then that will leave you with P over 2 minus W. And both of those answers are the same. So P minus 2W over 2 is fine, or P over 2 minus W is fine. But you just have to make sure that you simplify correctly. Now notice I put the note over here that you did not have to do it. And I'll show you a scenario in which you will have to do it. But in this case, you did not have to go any further past this expression. All right. Make sure we're okay before we look at another scenario. All right. Can I scroll up? All right. Down here, this is a scenario in which you would have to reduce, and they would be expecting you to do so. This is just a random example, just another. That's why I said if. That's why I put here if. If you had 4p minus 2w over 2. And like I said, the 2 in the denominator has to go to each term. So if I have this, once again, in order for me to break it down further, this 2 has to go to each term. And that'll leave me with 4p over 2 minus 2w over 2. So notice the 2 can go into the 4 and into that 2. That's the scenario in which you will have to reduce. I'm not even sure if you're going to get one, but I just want to make sure you know when you should reduce and when you don't have to reduce. When you go back to this one up top, there was nothing for the 2 could divide into in front of that p. So that's why you could leave it like that. But when you look at this one, you have a 4 and a 2 that can be divided into evenly. And so 4p over 2 minus 2w over 2 reduces down to 2p minus w. So that's what you'll be looking for. That's the scenario in which you would have to reduce. And that's if your denominator can divide into each term of your numerator evenly. All right. Make sure we're okay. Make sure we're okay. All right. Gonna scroll up. All right. Next one, we want to solve for A. We have 5a minus 3b equal to 7. And like I mentioned, we want to solve for A. So let's go ahead and move 3b. 3b's cancel on the left. And that will leave us with 5a equal to 3b plus 7. Then to finish it off, just divide by what's in front of a, which is that 5. And this is our final answer, 3b plus 7 over 5. All right. One more. Any questions before we do one more? Okay, the next one. capital I is equal to capital E over capital R plus lowercase r, and we want to solve for capital R. Only reason I'm emphasizing capital and lowercase is because I wanted to make sure we understand that we do need to keep the letter integrity when you go about solving your values, because capital R and lowercase r are two different letters, two different numbers, and they're going to hold you to that. So if you have to put in capital R or lowercase r in Weber's sign, then they're going to hold you to that. So if you use capital R but they wanted lowercase r and you just frivolously using r's, they can mark it wrong. So just be careful. In this case, we're solving for capital R, and once again, you know, those r's are different r's when we go to solve. All right, so we want to get capital R by itself, but we have to get it out of the denominator first. So we have I equal to E over R plus R. So to get the R out of the denominator, one of the ways is we can multiply both sides by that quantity of capital R plus lowercase r. So that capital R plus lowercase r will cancel out on the right. And that will give me I times R plus R equal to E. All right, next, because we still need access to this R, but we don't have it because of the parentheses, so we need to distribute I, you know, to remove the parentheses. So that'll give us I times capital R plus I times lowercase r equal to E. All right, still trying to get capital R by itself, so we're going to take over or send over I lowercase r to the other side by subtracting it. That'll give us I capital R equal to E minus I lowercase r. And then to finish it off, divide both sides by I. And R will be equal to, well, capital R will be equal to E minus I lowercase r over I. All right, questions? All right. Questions on anything before we at least start 9-2? All right. So let's get into 9-2. Rate, ratios, and proportions. So your rates, a comparison of two quantities. It can be written as a fraction. So that's 135 miles over 6 gallons. Or in other words, when you look at a division sign, 135 miles per 6 gallons. All right. A unit rate is a rate in which the denominator is 1. So if I wanted to convert that 135 miles per 6 gallons, or 135 miles for every 6 gallons, I would take that 6 divided into 135. That's 22.5. So I can read that as 22.5 miles per gallon. All right. Questions? Any questions? All right. All right. So we have a dental hygienist earns $1,304 for working a 40-hour week. What is the hygienist hourly rate of pay? So we want to know dollars per hour. All right. Remember I said per is your division bar or your fractional bar. So dollars would be on top, hour would be on bottom. So we take that 1304, place it over 40 hours. And then we go ahead and divide that 1304 by 40. Since we're dealing with money, well, I'll say this first. We got 32.6. Since we're dealing with money, that would be 60 cents. So you get $32.60 per hour. All right. Questions? Any questions? All right. So it says, which is the more economical purchase? An 18-ounce jar of peanut butter priced at $2.69, or a 28-ounce jar of peanut butter priced at $3.99. So the best way to evaluate, this purchase or these both of these purchases is to look at it in reference to cost per ounce. You want to know how much you're going to pay per ounce of peanut butter. So that's going to be dollars over ounces. So if we set up both of them that way, we can make a clean comparison between the two. So the first one is $2.69 over 18 ounces. So 2.69 divided by 18.149. All right. So that's 0.149 cent per ounce that you'll be paying for the first one. All right. Next one, $3.99 divided by 28 will give you 0.143 per ounce. So that's going to be the more economical purchase. You're paying less per ounce, even though it's a little bit, but paying less per ounce for the $4 purchase. All right. Questions on that? All right. All right. Next one, ratios. Just a comparison of two quantities that have the same units. And that may be written three different ways. If you're talking about as a fraction, it's 2/3. If you're going to use a colon, that's 2:3. And then with the word two, that's 2:2:3. All right. All right. So a survey revealed that on average, eighth graders watch. Somebody said something? Mm-hmm.
Yeah, can you go right ahead? I wasn't finished writing. Hold on one second.
So y'all be letting me just roll on, then y'all wait till I start reading, then y'all want to interrupt me.
I'm sorry.
You don't care. You don't care.
Dude, yes I do.
It's all good. Just let me know when you're ready.
Okay, thank you.
All right, not a problem. I know I heard another voice though. Make sure we good. I'm gonna go slow.
You good, big bro?
All right, cool. All right, so a survey revealed that on average, eighth graders watch approximately, so I did APP for short, approximately 21 hours of TV each week. Find a ratio as a fraction in simplest form of the number of hours spent watching TV to the total number of hours spent in a week. So let me remove these lines. We'll talk about put them back later, but give you guys a chance to copy that. All right, so reading it again, a survey revealed that on average, eighth graders watch approximately 21 hours of TV each week. Find the ratio as a fraction in simplest form of the number of hours spent watching TV to the total number of hours in a week. So, if we're talking about writing a ratio, remember keyword, and it was going to be two for us. The other one was colon and fraction. So this is the only time that it's given in word form. So we're looking for two. And so everything to the left of two will be our top number. Everything to the right of that two will be the bottom number. The one that calls for calculation is that total number of hours in a week. So, there's 24 hours in a day, 7 days in a week. So you multiply 24 times 7, that's 168 hours. All right. So 168 hours, that's going to be a bottom number because that's to the right of 2. And in front of that 2, we're talking about the number of hours that they spend watching TV, and that was given to us here, 21 hours. So you put that 21 over 168, and then you can reduce it because 21 times 8 is 168. That 21 cancels out completely, and that'll give you 1 over 8. Don't forget, if it cancels out completely, that's when 1 is left right there. So the 2 and 1s cancel, and we got 1 over 8. All right, make sure we're all right. All right, let's scroll up. All right, so our unit ratio is going to be a ratio in which the number in the denominator is 1, just like when we had unit rates, the number in the denominator was 1. So unit ratio follows the same thought process, having the denominator as 1. All right, so the next example gives us a mini chart. We have a university. OSU was Oregon State University, and then UO was University of Oregon. But you know, the names really didn't matter. The numbers do. So we're looking at how many men they have for students, how many women they have for students, and then the number of faculty in each. So it says calculate the student faculty ratio at OSU. So notice we're not talking about the University of Oregon, just looking at OSU. Round to the nearest whole number and then write using the word 2. All right. So we're looking at student to faculty ratio. So when I look at OSU, I'm going to add these two numbers together, 10,018 plus 8459. And that will give me the total number of students that they have at OSU, 18,477. And so I put that over the faculty, talking about student to faculty, that's student over faculty. So that's 18,477 divided by 1,471. 1,400, yeah, 71. Okay, just make sure I said it right. That's going to be 1256. So over here, 1256 over 1. Now it told us to round to the nearest whole number. So that's why I took that 1256 up to 13. And that would be a 12-to-1 ratio. All right. Questions on that? All right. So last thing in this section is proportions. Are we good before we go there? All right. So proportions, like I said, last thing, is a statement that says that two ratios or rates are equal. So an example of that, 2/3 or 2/3 is equal to 12/18. So basically saying that you have these two fractions that are equal to each other. That is a proportion. All right. So now what we will use as far as relationship to solidify if we have a proportion or not will be your cross products. It's just saying that if you have A over B equal to C over D, if that is a true statement, when you take your denominators up to the opposite numerator, you know, you're creating that X, taking the denominators up to the numerators, A times D would be equal to B times C. So Just an example over here. Taking that 2/3 and that 12 over 18, 12 eighteenths. Took my denominators up to the 18 to the 2, 3 to the 12. 2 times 18 is 36. 3 times 12 is also 36. So it's saying that if you truly have a proportion, when you take your denominators up to the opposite numerator and multiply, then you will have the same number on each side. All right, so we're going to use that principle to solve these proportions. If I have 8 over 5 equal to n over 6, and I want to know what would n be in order to make this a proportion, I would cross multiply. I'm just seeing something, playing around with this stuff. Yep, so 8 times 6 is 48. 5 times n is 5n. And then to solve for n, I would divide both sides by 5. Whatever's sitting in front of your variable, divide that into both sides. And that will be your answer. In this case, 48 over 5 went down to 9.6 if you divide it. All right, questions on that? So you take that thought process and that principle, you cross multiply, then you divide by the number that's sitting in front of your variable. All right, so this next one says if you travel 290 miles in your car on 15 gallons of gas, how far can you travel on 12 gallons of gas under the same driving conditions? Now remember, this is your proportions section, so we'll be using proportions to solve this. So you just want to make sure you're consistent in how you set up your proportions. I decided to use miles over gallons. There are a couple other ways to do it. You could have just done gallon over miles. Either way, just make sure you're consistent in what you're doing. So I forgot I had my eraser up again. We have 290 miles, 15 gallons. So I put 290 over 15. So when I set up my next ratio, it says, how far can you travel? That's your miles. That's going to be unknown on 12 gallons of gas. So that's why I did X over 12. So I did in both ratios, in both fractions, I did miles over gallons. So as long as you keep that same relationship, you should be fine when you set it up. In other words, miles over gallons in both fractions. And then you cross multiply, 12 times 290, 15 times X. All right, are we good? Let me scrolling up. All right, so 290 times 12 is 3480. 15x is on the right, so you divide both sides by 15, and we get 232. And you can drive or travel 232 miles on 12 gallons of gas. All right. Any issues? I think we got one more. Yep, got one more. Then we'll be good for today. This right here is just something that somebody asked about, so you don't have to copy that. So, all right. So last one for today, unless y'all want more, of course. The dosage for a certain medication is 2 ounces for every 50 pounds of body weight. How many ounces of this medication are required for a person who weighs 175 pounds? All right. So once again, you want to establish how you're going to set up your proportion, how you're going to set up each fraction in your proportion. I decided to do ounces over pounds. So I have 2 ounces for every 50 pounds. So that's the first ratio. Then it says how many ounces. So X is unknown. And then for 175 pounds. So that's what we're doing right here, X over 175. So from there, cross multiply. Like I said, same process. Cross multiply 2 times 175, 50 times X. That's 350 equal to 50X. Divide by 50. X is equal to 7. So that means a 175-pound person requires 7 ounces of this medication. All right. Questions, questions, questions. All right. So that's 9192, guys. We'll probably just do 93 next class. Yep, no problem. We'll just do 93 next class. And then we'll look at a review day, another review day set aside so you guys can ask whatever questions you want to ask. And then we'll look to move forward. Any questions, concerns, or comments before we close out today?
And just one more time, which homeworks was it that we have to do?
Oh, at this point, I got a whole bunch of scratch stuff down here. All right. At this point, we've covered 7.1 through 7.5. Yeah.
Okay,
And we've
perfect.
done 9.1 and we just did 9.2 today. So next class we'll do 9.3. And that's pretty much it for chapter 9 as far as, new sections.
Okay, thank you.
Mm-hmm. So somebody else said something in the chat. Sorry, when this home. So as far as the due date, I believe I initially said that chapter 7 was going to be due on the 21st. But I think what I'll do is let chapter 7 and chapter 9 be due that week of 5th week grades. We had to do that 5th week progress report for you guys. So I'll probably say that that's when all of chapter 7 and chapter 9 should be due or will be due. That way, if there's anybody still having issues getting into WebAssign, hopefully by then, all of that will be taken care of and it won't be an issue.
That's including the test, right?
Yep. All chapter 7 content, all chapter 9 content. Yep. And also don't forget scratch work. You got to send me a picture of your scratch work for your test, not for homework, but just for your test. Yep.
Do we have to send scratch work for the review?
No, not the review. Nope.
Okay, cool.
Yeah, just test. I know it's just asking for scratch work is a little cumbersome and worrisome anyway. So I'm just saying, just for
Yeah,
the
because
test.
I mixed mine up with my notes, so I don't know the difference.
Yeah. So,
Does the review count as a grade?
Say again now?
Does the review count as a grade?
The review is extra credit. You do not have to do the review. It's not mandatory, but if you score 85 or better on the review, I will add 5 points to your test. Yeah.
Can we use a calculator?
Yep. There's no way for me to govern that. So I'm not going to go to y'all houses and try to stop y'all from doing that. You know what I mean? So you'll be good to go. All right. Anybody? Anybody else? Anybody else? Oh yeah, I was gonna take a shot at you, Miss Baker. It's nice to see you here on time.
Not 2 hours early.
Right. Anybody else? Anybody else? Okay, somebody saying something in the chat. The test was very similar. Yes, that's why I say that you should at least take a look at the review. Even if you don't do it, take a look at the review. It will let you know basically how to streamline your studies for the test. Even if we have a test wherein I'm sitting here watching you and proctor you, always at least take a look at the review. Even if you don't do it, take a look at it. You'll know pretty much what's going to be on the test. Yep. So that was one of your classmates trying to give you a heads up. So anything else, anybody else before we close? Everybody good? Everybody straight? All right.
Nah, big bro, you got it.
All right, appreciate that. So y'all have a good one. Let's see, hold up. Somebody said, okay. Yep, somebody sent me an email. Yep, I'm gonna check that. And outside of that, you guys have a great one. Y'all be safe. I'll see you on next class. And take care.
Okay, have a good day.
All right, y'all do the same. Thanks.